What's up, guys? Welcome back. I hope you guys are getting something out of this. I'm not trying to bedazzle you with, CGI and fancy computer work and this, that, and the other. I'm here to give you some make sense, reality based things that you can, wrap your brain around so that you can begin to understand the world that you're living in. Okay, and so as we're looking at all these things, one of the most complicated, and I'm going right to all of these things that are super complicated because they're not. They're not complicated. They want you to think they're complicated, but I'm here to tell you that they're not complicated, okay? We're going to talk about perspective and the curvature of the earth today. And these are they seem to be complicated and maybe, but just follow me because this is not that complicated, okay? I'm going to get right to it. So, the accepted circumference of the earth is 25,000 miles around at the equator, okay? That's the circumference. Listen, science is screwed because they're stuck in the has to be's. It has to be 25,000 miles around in order to spin around once in 24 hours in order to explain what we observe. It has to be according to their model, and this is where they get stuck. They get stuck in the has to be's. But understand, it has to be 25,000 miles an hour or their model doesn't work. So at 25,000 miles around at the equator, that gives us a curvature formula, a very simple curvature formula, a very simple algebraic expression, 8 inches per mile squared. We would write this out as 8m squared. Very, very simple formula. If you've been to Algebra 1, pre-algebra, you know how to do this. Okay, order of operations, it's very simple. So let's say two objects are 10 miles apart. We would go 8 times 10 squared, right? Order of operations, PEMDAS, right? So we got 10 squared. 10 times 10 is 100, times 8 is 800 inches. At 10 miles apart, two objects, there should be 800 inches of curvature between those two. That works out to 66.6 feet. There we go again. We're going to round it up to 67 for sake of, because we're not Roman Catholics. All right? So what this means is that for two people standing 10 miles apart, in order to draw a straight line between them, a straight line, you would have to tunnel under the earth. You'd have to tunnel under the earth at an angle, right? Directional drilling, right? We'd have to do a directional drilling action through the earth in order to draw a straight line to meet this other person 10 miles away. And at the deepest point of that tunnel, it will be 67 feet deep. Okay? In order to draw a straight line between these two, that's how much curvature there should be. Okay, but let's talk about what we observe. I'm going to use something simple like city skylines. Okay, for example, let's talk about something like New York City, Chicago. We got some of these cities that that have skylines that are miles and miles wide, bro. Okay, miles. Okay, and so, but what you will find is that no matter how wide a city skyline is, all of the buildings are perfectly parallel to the earth. They have to be. Well, they all are, right? Well, except for like what the Leaning Tower piece. Did it ever fall down? I don't know. Did they take it down? I don't know. Fact check me. I don't know. Okay, with exception to the Leaning Tower of Pisa, right? Okay, buildings, according to our structural engineers, right, are perfectly perpendicular to the earth. But what we also find is that they are perfectly parallel to one another no matter how wide you go on the skyline. Now, you may say, oh, well, 8 inches per mile, that's not a whole lot of curvature. And I would agree, at 5 feet off the ground, 8 inches of curvature doesn't seem like a whole lot. But when you talk about these skyscrapers that are hundreds and hundreds and hundreds of feet in the air, they should begin to fan out. They should begin to fan out. They should not maintain a perfectly parallel situation with one another while being perfectly perpendicular to the earth. Look, 90-degree angles are I eat off 90-degree angles, okay? So just, this is not complicated stuff, guys, all right? These buildings are perfectly parallel and perfectly perpendicular to the earth at all times. Now, why do things appear the way they appear? Well, I'm going to talk about perspective real quick because this is the issue, because this is how these things equate into the real world. Okay? What I want you to, first of all, imagine as you're down a hallway, my horrible drawing here, right? You're looking down a long hallway. And as you're looking down the hallway, you see the lights, right? The light closest to you is the biggest one, and then the next one seems smaller, 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 right? And what it appears is that the walls are coming in, the ceiling is coming down, and the floor is coming up. And if that hallway were long enough, it would all disappear at what we call the point of convergence. That's what this right here represents, is your field of vision. What perspective and the point of convergence is, that's just the limit of your vision, bro. It's just the limit of your vision. That's all it is. Okay, because I built that those walls, and I'm here to tell you that it's just as wide down at the other end of that hallway as it is where you're standing. Just as wide. And it's just as high to that ceiling, and it's just as low to that floor. Okay? But what has happened is the limit of your vision has brought them all to a point of convergence. And that's what we're literally dealing with when you're looking at the sun appearing to rise and set. It is the limit of your vision and the point of convergence. So, and let me demonstrate how this should work, right? Okay, so if you are standing 10 miles apart from another person, okay, first of all, 10 miles apart with a 67-foot curve between you, you should not be able to see anything 10 miles away that wasn't at least 70 feet tall. And even then, you should only see the very tip of the top of it. You shouldn't see the whole thing down to the ground. No, but that's not what you see. What you see is the landscape in front of you, whether you're on the ground or in a plane. What you see is that the land appears to rise, the sky appears to sink, and everything disappears off into the point of convergence. And that is just the limit of your vision. Simple. That's all it is. Because if you watch a boat go over the, as they say, it went over the curve of the horizon. Well, no, that's just your vision, bro, because if you pull out a pair of binoculars, it comes right back into view. And you can watch it with the binoculars until it goes out of view of the binoculars, but then if you pull out a telescope, it will come right back into view. So what we find is that it is only the limits of our vision that keep us from being able to see. If you have strong enough zoom, you can see as far as your zoom will allow. And no matter how far away you look, what we see is the same, unchanging, without regard to altitude, anything like that. No regard to how high you are or low you are. No matter how high you go up, the horizon always meets you at eye level. And no matter how high you get up, you never see the edges begin to curve away, which you should, because the Earth is not that big. According to science, it's only 25,000 miles around. Think about how long it takes you to drive 25K miles, bro. You drive around the Earth twice a year, bro. Or do you? Or do you? Just saying.